In this video, I'm going to solve this question. Let's start with part A. In how many different ways can the letters of the word exam be arranged? So that means in part A, we have to find anagrams of the word exam. So we have to find anagrams of this word. Well, this part is quite trivial and we do have a rule as well that we can use to answer this part, but just for the sake of completion, let's proceed logically. So because we are dealing with a 4-letter word, let's create 4 slots here. Note that there is no condition given here, so we can start with any of these 4 slots, and let's say we start with the first slot. So the first slot can be filled in 4 ways, and let's say we write M here. Having filled the first slot with the letter M, we can fill the second slot in 3 ways. Similarly, we can fill the third slot in 2 ways, and we can fill the fourth slot in 1 way. Now, because we are filling all these slots, so this is 4 ways multiplied by 3 ways multiplied by 2 multiplied by 1. So this is equal to 24, or you can also write that this is equal to 4 factorial. So this is about part A. Now let's have a look at the rule that you could have used to answer this question directly. So the rule is that the number of permutations or arrangements of n different things taken all at a time is given by npn, that is n factorial. Well, we could have used this rule to answer the part A. Note that in part A, the word that is given to us is exam. So all the letters are different. So that means we have n different things here. And if we have to arrange this n different things, then this can be done in n factorial ways. So the answer is 4 factorial. As I said, this part is quite trivial. So now let's move to part B, which is relatively more interesting. In how many different ways can the letters of the word food be arranged? So that means in this part, we have to create anagrams of the word food. Well, we do have a rule to solve these type of problems as well. But for now, let's forget about the rule and let's try to solve this problem logically. So note that this word has 4 letters. So first of all, let's create 4 slots here. Now the question is, can we solve this question just like we solved part A? Well, let's see. So that means, can we say that the first slot can be filled in 4 ways here, and the second slot can be filled in 3 ways, the third slot can be filled in 2 ways, and the fourth slot can be filled in 1 way. So that means, can we say that the letters of the word food can be arranged in 4 factorial or 24 ways? Well, the answer is no. This is not right. Now let's have a look at the logic that why is this not right. The answer is that we have 2 O's here, and these 2 O's change the entire game. To understand why this method is not right, let's make a small change here. Let's say that these 2 O's are different. So let's say that this is O1 and this is O2. So that means the word that we have is F, O1, O2, D. Now let's write some of the possible arrangements of this word. So let's say the first arrangement is O1, O2, FD. Another possible arrangement could be, let's say, FD, O1, O2. Or one more possible arrangement could be O1, FD, O2. So these are 3 possible arrangements that we have here. Now note one thing here, because I have assumed that these 2 O's are different, that means that this arrangement O2, O1, FD is different from this arrangement. Similarly, the arrangement FD, O2, O1 is different from this, and the arrangement O2, FD, O1 is different from this arrangement. But in actual, are these 2 arrangements different? Well, the answer is no. These 2 arrangements are not different because we do not have O1, O2. What we have is O. So that means every possible arrangement is counted twice if you follow this question using this method. And this is because the O's here can be arranged in 2 factorial ways. That is the reason we are facing the problem of double counting here, because these 2 O's can be arranged in 2 factorial ways. So what do we do now? How do we correct this problem of double counting? Well, the solution is you divide the total number of ways that you calculated earlier by 2 factorial. And this will take care of the double counting. And this is the answer. Note that this method is not the best method to solve the type of questions in which letters are appearing more than once. The only reason I have showed you this method is so that you could understand what's happening in the background. Now let's have a look at the rule that we can follow to solve these type of questions. So the rule says that number of permutations of n things taken all at a time in which p are of one type, q of them are of second type, r of them are of third type, and rest are all different is given by n factorial divided by p factorial, q factorial, r factorial. So in our case, we have 4 letters. So that means n is equal to 4. And the letter O is appearing twice. So letter O is appearing 2 times. So you can say that P is equal to 2. So now we can just use this formula to find our answer. According to this formula, our answer should be 4 factorial divided by 2 factorial. And that's it. Now let's move to part C and let's use this rule to find the answer to that part. So in part C, we have to find the anagrams of the word attention. So this is the word that we have. Now, first of all, count the total number of letters that you have. Irrespective of whether the letters are repeating or not, just count the total number of letters that you have. So in this case, we have 9 letters and this becomes your n. So your n is 9. Now count the letters that are repeating. So we have 1 T here, 1 here and 1 here. So that means T is appearing 3 times. And we can count that n is appearing 2 times. And all the remaining letters A, E, I, O are appearing only once. Now let's use this formula to find the answer. So according to this formula, the answer should be 9 factorial divided by 3 factorial multiplied by 2 factorial. And that's it. This is your final answer. And with this, we are done with this question.